Good morning, students of class 6. Actually, you want to study changes around us, so I would like to explain this chapter today. Please watch this video with your textbook. Okay, please turn to page number 68. I am reading it out, and please take a pencil also. Whatever I ask you to underline, please underline. Okay, turn to page number 68. On page number 68, you will see reversible and irreversible changes. There is a topic called reversible and irreversible changes. Please underline the definition of reversible changes. Changes that can be easily reversed by removing the cause of the change are called reversible changes. Please underline this with pencil. Changes that can be easily reversed by removing the cause of the change are called reversible changes. Now don't underline. I am just reading it out, you will just follow me. For example, wax is solid at room temperature but melts upon heating. The melted wax becomes solid again when cooled. This is a reversible change. Similarly, the melting of ice is a reversible change. So students, what they are trying to say is actually change of state of matter is actually a reversible change. You know that there are basically three states of matter: solid state, liquid state and gaseous state. Okay, so when solid melts, for example, ice melts to form water at 0 degrees Celsius and water freezes to form ice at 0 degrees Celsius. So these are actually examples of reversible changes. Okay. Next para. Please follow. However, some changes cannot be reversed. When a candle is lit, the wax burns and produces heat, light and soot. We cannot bring back the wax that was burnt. Changes that cannot be reversed are called irreversible changes. Please underline this definition, students. Changes that cannot be reversed are called irreversible changes. Please underline these also. The burning of a matchstick or a piece of paper is an irreversible change, as the ash cannot be changed back to the matchstick or the paper. You see, when the matchstick burns or when the paper burns, after some time you will see that only ash is left. Now you cannot change the ash to the paper, or you cannot change the ash to the matchstick. Oh, okay. So this is an example of irreversible change. Please underline: the germination of seeds, the growing up of a child, the breaking of a glass, the cooking of rice, the baking of bread, the bursting of crackers, the death of a person, the decay of food and the changing of milk to curd are some examples of irreversible changes. Underline this paragraph. Okay. Now see, there is a topic called physical changes. Okay. Now you will see that there is something printed in italics. Changes that involve only a change in the physical properties of the substance but where no new substance is formed are called physical changes. Children, I have told you earlier also that physical changes are those changes where there is a change only in the physical properties of the substance. That means no new substance is formed. Okay, there is no new substance formed. There is a change only in the physical properties. So please underline that definition of physical changes. Changes that involve only a change in the physical properties of the substance but where no new substance is formed are called physical changes. Now physical changes can be reversible or irreversible. Let's come to reversible physical changes. Page number 69, change of state. Water changes to steam on heating and to ice on cooling. In every state it is found in, water is made up of only water molecules. No new substances are formed. Water can be changed from one state to another by heating or cooling. Thus, change of state is a reversible physical change. I told you that when ice is heated, it melts to form water, and when water is boiled, it is transformed into steam. Okay? Again, steam condenses to form water, and water freezes to form ice. Okay? Okay, so you see these are basically examples of reversible physical changes. That means no new substance is formed. There is no change in the physical properties. Dissolution. When a solute is dissolved in a solvent, a solution is formed. This process is called dissolution. Please underline this. When a solute is dissolved in a solvent, a solution is formed. This process is called dissolution. Okay, till this much you will underline. Now follow me. No new substance is formed in the process. The solvent can be separated by distillation. Please underline this. The solvent can be separated by distillation. The solute can be obtained by evaporating the solvent. Underline this line also. The solute can be obtained by evaporating the solvent. Thus, dissolution is a reversible physical change. Underline this paragraph. The full paragraph of dissolution you will underline. You see, when you dissolve sugar in water, okay, what will happen? You will see that when you put some sugar in water and then stir it with the spoon, you will see that it gets dissolved. Okay, now what you will do, you will try to evaporate the solvent. Okay, after evaporation you will see that the sugar is left behind. Similarly, salt, when added to water and then you stir it with the spoon, you will see that the salt is dissolved. But when you do the evaporation, you will see that the water gets evaporated but the salt is left behind. So this is an example of reversible physical change. So dissolution is also an example of reversible physical change. Expansion on heating. Almost all substances expand on heating and contract on cooling. Please underline this. This is a reversible property which is used by blacksmiths to fix metal rims on wooden wheels. The metal rim is made slightly smaller than the wooden wheel. When heated, the rim expands and becomes bigger in size. This hot metal rim is fixed on the wooden wheel and cold water is used to cool it. The metal rim contracts and fits the wooden wheel tightly. Please underline this full paragraph. Thank you, students.